Hey guys, do you remember the movie Arrival? That was a 2016 film about humans first making contact with extraterrestrials and the linguists tasked with figuring out their language. The aliens communicate in heptapods, which is a system of glyphs that defy human comprehension. The major premise of the film is that their circular symbols represent ideas in relation to one another, not individual concepts. Well, astronomers using the James Webb Space Telescope have decoded a series of signals coming from beyond the Milky Way, but the communication also involves mathematical sequences, spatial representations, and an unexplained clock. These mysterious transmissions originated from a globular cluster of stars about 29,000 light years from Earth. Globular clusters are spherical groups of hundreds of thousands of stars held together by gravity. Our own galaxy contains about 150 of these clusters, but they're relatively common throughout the universe. This particular cluster is called M55 or NGC 6809. It contains around 150 billion stars and several dozen known neutron stars. Astronomers first noticed these radio signals in 2020 using the Fast Radio Telescope in southwest China. They attempted to track the source, but the signals seemed to come from everywhere inside the globular cluster. The team at FAST didn't think much of it and continued monitoring other targets, but 2 years later, astronomers were able to use the James Webb Space Telescope to identify the exact origin of these signals, and what they discovered will change our understanding of the universe forever. The star responsible for sending these radio signals is officially designated M55 NR 224944. It's a highly magnetized neutron star roughly 8 times heavier than the Sun, packed into a sphere less than 10 kilometers wide. Most neutron stars emit regular pulses of radiation, aka pulsars, but this pulsar emitted radio waves in uneven bursts. It didn't send out a consistent rhythm like Morse code or binary language. Rather, the signal was akin to a few notes on a piano, repeating in a random sequence. These transmissions seem to be fast radio bursts, a type of intense but short-lived burst of radiation. We have heard them before, but not from such a close range. You see, this globular cluster M55 is relatively close to Earth. But the thing is, radio telescopes on our planet cannot detect signals originating inside globular clusters. The dense stars block our view. This is why it took JUICE to figure out where the signal was coming from. And now that we know the star is located inside a globular cluster, that raises a lot of questions. You see, globular clusters are densely packed groups of ancient stars. They're extremely hotbeds of stellar activity. Neutron stars, white dwarfs, and black holes reside within these clusters, emitting massive amounts of energy, blasting apart young stars and creating conditions ideal for chemical reactions. This particular cluster, M55, is home to an estimated 15 trillion Earth-like planets. Most of these planets are likely tidally locked to their stars, but many of them could support life under the right conditions. Even better, we've already discovered water and organic molecules within this globular cluster. So far, there are no confirmed exoplanet orbiting M55. However, we can rule out the possibility that one or more worlds exist within this cluster that could harbor life, and if that's the case, then who or what is communicating with them? Before we continue, now let's get back to the video. The weird thing about this globular cluster is that it's very old. Stars born in M55 are between 12 and 15 billion years old. This makes the cluster one of the oldest objects in the Milky Way, and it might be the reason we're hearing signals from within. You see, the average age of neutron stars in globular clusters is much older than the rest of the stars. This is because neutron stars take millions of years to form. They're created when massive stars collapse, but it takes many lifetimes for enough material to accumulate in space. So while the stars surrounding M55 are ancient, the neutron star at its center is much younger. It's possible that this pulsar, along with others in the cluster, is trying to communicate with civilizations that existed billions of years ago. But how can that be possible? Well, globular clusters move through the galaxy. They drift in and out of our solar neighborhood every 250 million years. M55 is passing through the galactic core right now, but it will eventually pass beyond the disk of the galaxy, and when it does, it will face the unknown. There are many things waiting for us out there in the depths of space, things that are both beautiful and horrifying. Most of the globular clusters in the Milky Way are tightly Bound systems, meaning they travel as a unit. However, some of these clusters are unbound. They've formed temporary associations that will eventually drift apart. It's believed that M55 is an example of an unbound cluster, and it will split up sooner or later. At that point, the neutron star at its core will be flung out into the abyss. We've already seen evidence of solitary neutron stars adrift in space. Some of them rotate rapidly and emit beams of radiation, which we can observe as pulsars. Others are dormant. But if M55 breaks free of its cluster and enters deep space, its pulsar will become active once again. It will begin communicating with whoever is out there, but who is it trying to reach? What we consider to be intelligent life may be billions of years old. Human beings have only recently entered the grand stage of the universe, and we're going to need a little help from advanced alien species if we want to survive. You see, life on Earth is incredibly rare, despite the vastness of the universe. If we're truly alone in the cosmos, then the odds are astronomically against us. Of course, just because we haven't found life elsewhere doesn't mean it isn't out there. We may live in an extremely small corner of a tiny galaxy in a relatively unremarkable section of space. But if we're truly the only sentient species in the Milky Way, that would mean there's something preventing other forms of life from evolving. And I'm not talking about any universal impediment that prevents life from arising in the first place. I'm talking about something that keeps civilizations from reaching their full potential. So far, we've never seen another civilization in the Milky Way because the universe hasn't given us permission. Maybe we aren't supposed to find anyone else. Throughout history, there have been countless species that rose to prominence only to disappear. Dinosaurs, Neanderthals, mastodons, every living thing on the planet today will die, leave behind fossils, and turn to dust. The universe isn't big enough to preserve the remnants of every civilization that arises. But if intelligent life is out there, it probably has limits. There's a reason why scientists refer to this period in history as the Great Filter. Let me explain. As humans, we're pretty destructive. We've wiped out entire ecosystems and poisoned our own atmosphere. But we haven't reached our full potential yet. It's entirely possible that future humans could terraform other planets, cross the stars, and colonize the galaxy. But we haven't done that yet. Therefore, we are still behind the Great Filter. There's something stopping us from achieving true greatness. Either that or we're not smart enough to do it yet. But it's possible there are other species out there that have broken through the filter. If that's the case, then there's no telling what kinds.